for an example, let's look at upsizing a bridge from the existing condition to accommodate flood flows. So once I duplicate this, I know that most of the yellow cells have been filled in and are accurate. However, we need to change the information that we are assuming would be the mitigation solution. In this case, if we're upsizing the bridge, we may want to increase the length. Let's say we're increasing it 20 feet. And let's see, maybe we're also widening the bridge as well if this is part of a roadway improvement plan or something like that. In this case, where we're looking at a mitigation option, we are going to have to put in data from a design or from a proposal, or in the case of looking at superstructure and substructure and scour conditions, we're going to have to make our best judgment call in updating these values. So again, you can reference the structure inspection report to understand what these variables are in existing conditions, but for a proposed condition, you'll have to use your best judgment in updating this data. As you can see, I updated the 6 cells here. However, I am assuming that these other variables will stay the same. If you want to account for the annual daily traffic increasing, you can also put in assumptions here. I should also note that the detour information would probably stay the same as well. However, if you want to account for any other different variables or assumptions, you can input them here in row 99. And once again, we can walk through the steps. So step 3 calculates owner consequence. Step 4 is owner consequence. Step 5 is vulnerability assessment. So if we need to update any of these variables, we can. And step 6 is risk assessment. One other thing I should mention is down below in table 3.8, there is a unit cost table. So this unit cost is pulling from a bridge because we're looking at a flood bridge tab. And it is identified that a bridge is on average about $600 per square feet, $600 per square feet. This is then used in the actual replacement cost. This can be found in the ARC row 110. The actual replacement cost uses the structure dimensions with the unit cost to come up with an estimated replacement cost of this structure or CDOT asset. This is really important and a really helpful variable. It should be noted, though, that this is an average estimate of unit cost. So this is a great tool for planning or pre-scoping or scoping level identification. If you want to get a better, more complete analysis of replacement costs, please use the project cost spreadsheet tool. However, from Brian Varela's and my experience, we have seen that the actual replacement cost here in the risk and resiliency spreadsheet tool is very similar and in the same ballpark as the project cost spreadsheet tool. So again, this should be used for planning level analyses. And as you move further along in a project, always refer back to the project cost spreadsheet tool.